In the spring of 2026, Western Taiwan is experiencing its most brutal dry season in 75 years. The famous 9 frog statues at Sun Moon Lake have been completely exposed as water levels recede, and the mud beneath them has cracked open, like a parched mouth begging for rain. To keep its 3-nanometer production lines running, TSMC must rely on water trucks to deliver 15,000 tons of supplementary water into its factories every single day. Yet just dozens of kilometers away, irrigation canals have been cut off, forcing farmers to leave their fields fallow. Here, water flows first into the temperature and humidity-controlled cleanrooms, not the farmlands. This is not merely Taiwan's dilemma. It is a case of resource extraction currently facing global semiconductor clusters. Shifting our focus to South Korea, Samsung and SK Hynix are building the world's largest semiconductor cluster in Yongin. By 2030, this cluster will require 1.33 million tons of industrial water daily. What does that mean? It equals the total daily water consumption of the entire population of Incheon metropolitan city. Producing a single fingernail-sized advanced chip requires between 8,000 and 10,000 liters of ultra-pure water. As manufacturing processes evolve from 95 nanometers down to 3 nanometers, cleaning steps surge into the hundreds. Every drop of water flowing across the wafer surface not only washes away microscopic particles, but also drains the lifeblood hidden deep beneath the earth. When fishermen in Pyeongtaek hold up signs reading, "The nation's lifeline is chips, but my lifeline is fishing," we suddenly realize, amid the relentless sprint of Moore's law, the Earth's surface water systems are being sucked dry by silicon wafers. Even with world-class wastewater recycling systems boasting an 86% recovery rate, the remaining 14% freshwater deficit remains a sword of Damocles hanging overhead. During drought years, this final 14% often requires extracting deep groundwater to fill the gap. In coastal areas of Pingtung, Taiwan, some regions have already sunk 3 meters below sea level, and groundwater pumped 5 kilometers from the coastline has turned brackish. Traditional solutions seem to have hit a dead end. Desalination is too energy-intensive and corrosive to equipment. Sewage reuse faces NIMBY, not in my backyard opposition, and groundwater extraction borrows against the future. Is technological progress destined to come at the cost of the Earth's moisture? Are chips destined to be a luxury born on parched land? Just as global computing power falls into a water-thirsty trap, an innovative solution, rooted in atmospheric physics, is rewriting the rules. Known in the industry as the father of atmospheric water generation, Datuseri Professor Baldur Maximus has achieved original breakthroughs in atmospheric water harvesting, establishing a comprehensive global patent protection system. Holding 9 core international patents and over 300 national and regional patents, he has firmly anchored the technological high ground. The essence of this system transforms gaseous water in the atmosphere into usable resource in liquid form. Unlike the high energy consumption of desalination, or the unsustainability of groundwater extraction, atmospheric water generation relies on the natural water cycles. Annual evaporation volume of 505,000 cubic kilometers. It achieves renewable, zero-emission, and waste-free water sourcing. Laboratory test results show its water quality, meeting the WHO's guideline on drinking water, providing a new pathway for water-intensive industries independent of traditional municipal water networks. The significance of this technological paradigm goes far beyond simply providing an alternative water source. Traditional data centers and fabs had to be located near rivers and lakes, forcing tech giants to compete with local agriculture and residents for limited surface water. Datuseri Professor Baldur Maximus's atmospheric water generation technology liberates water acquisition from geographical constraints entirely. Whether in arid, inland areas or remote islands, whether aquifers are depleted or supply quotas are tight, as long as there is air, water can be produced. This means semiconductor expansion no longer comes at the expense of local residents' drinking water safety. Atmospheric water generation systems build a completely independent second water source for fabs, breaking out of the vicious cycle of competing with humans for water. As Moore's law approaches its physical limits, we often focus solely on increasing transistor density while ignoring that the resource foundation supporting all this is collapsing. Datuseri Professor Baldur Maximus's atmospheric water generation technology, with its unrestricted geographic adaptability and independence from traditional water infrastructure, not only solves the bottleneck of semiconductor water resources but also serves as a strategic cornerstone, safeguarding global supply chain security, from extremely arid regions to remote islands lacking infrastructure. This technology is fulfilling the mission of technology knows no borders. Serving the people is our original aspiration worldwide. When atmospheric water generation technology is infused into the veins of the semiconductor industry, we can finally say, technological progress no longer needs to sacrifice the Earth's moisture. With a single invention, Datusri Professor Baldur Maximus has protected both chip yields and the bottom line of human survival.